Oh, and this meeting is being recorded. All right. Am I sharing the right screen? Awesome.
Yes.
Okay. So normally my partner in crime is Rita Foster. She has like 30, 35, 100 years of experience in infrastructure security. She's a strategic advisor at INL Lab, and I can't say enough good things about her. And we are sort of tag teaming this internal research on Zero-Trust here at Idaho National Lab. And we lovingly call it integrating Zero-Trust principles into IIoT architectures. So this is kind of just where it started. We care a lot about things being very evidence-based and codified. So that's where we sort of started with this, and how we sort of pitched it to leadership to get the funding that we needed. So the stuff that we focus on here, our devices commonly found in building technologies. We'll use the word codified a lot, which means that we're actually putting into a reasonable format some of this information that we're looking at. We care a lot about the Zero-Trust principles, but not just on a networking scale, but clear down to different levels, such as like firmware, and using the appropriate information that makes sense to most people, right? So if you're using your own data format, who really cares, right? It's like, I don't think anyone on here is going to go look up Shaya Wolf's data standard that she made up in 2019, so we use international data standards that people actually care about and are going to be able to better integrate into their own systems. Almost everything we do is modeled in graph theory. We definitely specialize in a lot of graph learning technologies and machine learning and AI. So from sort of a jumping off point from here, we try to make sure our data is in a format that we know we'll be successful with later on down the road for future projects. Graph theory really does kind of win the race as far as helping people and machines both understand the connections between things and making sure that that information is, again, codified. Our main goal that we used to get the funding for this project was mathematically proven defenses. So I'm very particular about the words measures and metrics. If you say metric to me, I'm a mathematician. I expect the triangle like inequality to hold. I've got like principles to stand by. So we're a little picky about those terms, but it's only because I'm me and I'm weird sometimes. And then, so what we're doing in this year is gathering our measures and measuring different points in the system, and then finding ways to create those into like real life metrics, not just things that you make up and they feel good to you. And then, like I said, this is like a building technologies model. It's very implementation specific. We've been doing this work for a little over a year, so we're not too far into it yet, but we have the devices, we have the people, and we're chugging right along. So with that, we kind of started with this hypothesis that zero-trust architectures with distributed resilience enables provable system validation and security assurances. So the first year, what we focused on was building up that architecture and instrumenting it for resource providing measures, which basically means that, we get it all codified into graph. We have it all, we have our network diagrams that everybody has, but we also have different views of that so that we can see it from different angles. A data scientist is going to have a different view than a mechanical engineer because different things matter to us. We define our metrics from our measures. That's what we're working on currently. And then next year, we get to do more of my favorite part, which is the data analytics toolkit, where we can take those measures and metrics. We can do some graph analytics. We can start doing the machine learning and the AI, which is where I specialize in. I'm a data scientist by trade and mostly specialize in AI and ML, but sometimes I get pulled into stuff like this. So our current challenges is that a lot of system architectures lack the ability to frame some of those individual components in a way that's useful. So everything that we do needs to be usable and useful. It's not enough just to put a number on a dashboard that doesn't do anything. It doesn't give us anything. So we're really trying to work on expanding boundaries there. And then also our Zero Trust products are mostly network and server based, not OT. So this is from Forrester Research. There's a lot of different pictures that you'll see when you like Google Zero Trust. Most of them are from CyTE. This one doesn't get as much love in the world, so we put it on here just so that people can kind of see a different way of looking at it. We like it because it puts data and assets right in the middle, but it still works on everything from devices to workloads, users and identities, and then also networks, right? And then we also really enjoy these like cross-cutting capabilities of visibility and analytics. That's huge for us in our data analytics, is having visibility. That's why we do it. So a lot of our goal in the Zero Trust is to provide that visibility to people in a usable way. And then also the automation orchestration that we're focused on in year 3. So speaking of CyTE, we do still care a lot about what they say. They're kind of leading the charge in a lot of ways here. So the maturity model that we focus most on is the subsection of data and assets. So we just put this here on the slides just for like reference. But essentially how it works is you have the traditional means. A lot of people will focus solely on like encryption or authorization. So we like that CyTE kind of breaks things down and tells you, okay, well, it's actually across all of these different measures, and this is just data and assets. So they work up from traditional to initial work in Zero Trust, and then people who are more advanced at it, and then where you're getting to the optimal, now you're running some true Zero Trust architectures. This is the other one that CyTE will put out a lot. This is probably if you were to go out and Google Zero Trust right now and then click on images, you'd get this one, this table. So it's the same thing. They're going traditional up to optimal. And then here you kind of see not just the data, but also the identity, devices, networks, that sort of stuff. So a lot of the identity comes down to like some multi-factor authentication, authorization, whichever way you want to say it. Possession of mobile devices with application registry. Our devices vary a lot. We do have a lot of ARM processors, which provide us with very little visibility into the system. We do work a lot on the networks. We always say that we're not focusing just on the networks, but we do work a lot on the networks. And then applications and workloads, everything from web browsers to command lines. We do pay particular interest to anything that goes up to the cloud, because that's a different ballgame. So that kind of leads us to why do we care? So why Rita and I kind of got into this game was because we were focusing a lot on edge devices, small devices, and the security problems with those. So as a starting point for Zero Trust, you always hear authentication and authorization. We're just going to whitelist people and we're good. And what we mean by like we're not just focused on the network is that we're really focused on those actual devices. So securing edge devices takes more than just that, sort of initial approach of authentication authorization. So for what we're doing, we are doing a lot more of like the assessing firmware, monitoring that hardware integrity, finding ways to search for compromised hardware. A lot of that references back to some of our early work where we do a lot of machine learning on different aspects of firmware and such like that. So really, we're just pulling that research along, but it works really well in this larger conversation about Zero Trust and edge devices. And then one of the newer topics that I've been reading about, it's not like super new, but when they say like Zero Trust edge, really what they're talking about is Zero Trust at those edge devices. And it's selling really well, right? Because you're reducing risk, you have cost savings, you're enhancing the user experience. What it really does for us is give a name to some of the research that we've been doing for the last couple of years and understanding, right, that it's kind of now coming into focus for a lot of people. So then I just put this clip on here from this Forrester article. It's really the first I ever saw on Zero Trust Edge. So like I said, it's not like brand new, it's 2021, but this is kind of something that's gaining a little bit more traction now. So, and Forrester was the one that had like the first image with the circles. So it's all a circle. So I'm full of really lame jokes. So if you're not ready for that, I understand. Along with edge devices, we also look a little bit into edge AI. So where our head's at right now is more functionality usually means more vulnerabilities. So NVIDIA just released, what is edge AI and how does it work? Makes sense for NVIDIA, right? Because they're selling the computation power that makes it work. So we put on here some of the like pluses and minuses that they list. They list them all as proponents. Some of them maybe I personally disagree with, but this really comes around because we have better neural networks, better compute infrastructure, and there's a lot more IoT device adoption, especially in IIoT, building technology, stuff like that, which makes it a perfect fit for the zero trust work that we're doing. So the first three, yeah, totally agree. Real-time insights, there's lower cost and higher availability. The next three are a little bit more contentious. So when they say, we have more intelligent devices if we embed them with AI, you have more intelligent devices if it's done right. If it's done wrong, you have scary intelligent devices that aren't to be feared, but they're not to be trusted. As far as increasing privacy, in theory, you're increasing privacy because you're not sending your data back to a cloud, but all of that data is sitting in some way, shape, or form on that edge device that remains vulnerable. And then as far as persistent AI improvement, AI models that consistently take in data and make changes based off of that are provably more vulnerable than models that are trained under more controlled processes. So the more data that you're throwing in there, kind of the wider your attack surface is. So as far as persistent AI improvement, I would say, yeah, maybe, but with a lot less protection for that AI. So, all of that points to the main problem. Edge devices are vulnerable, and AI ML isn't supposed to say secure. I do know how to spell. I just don't do it for my day job. So my apologies on that. So speaking of vulnerable, if I were to go down just a little tiny rabbit hole here, and along with this sort of idea of edge devices, we see a lot more attacks on UEFI and biosystems. So we've got boot hole, logo fail, pixie fail. Those are all groups of vulnerabilities that are exploitable, not necessarily exploited, right? But they're exploitable in a lot of our systems, especially things like Grub2, image parsers, data centers, either commercial or private. And then we have a list here of different malware that we've seen come through the years that does specifically affect that UEFI. And the problem with this malware, right, is that once it's infected some of these edge devices and some of these smaller devices, right, you're talking about something that can survive a reboot or even like a reformat. So now you're talking rip and replace costs because people don't just, solder their own boards. It's cheaper to just buy a new board than it is to pay somebody to solder it. So it has a lot of implication right now, especially in a lot of these IIoT architectures, right? That we're starting to see a lot of this malware. So we have a firmware analysis tool called Travolta. It springs from like a different version that was called Disco at Disco. So I always love to include this Travolta when Rita's not here because she hates it. And but really what we're looking for is semantic similarity in some of these like malware samples. So back in March 2022, we were able to show, well, actually Conti and like common malware samples from the threat actor group Conti really look a lot like and have a lot of semantic similarity to parts of trick boot samples, which is something that affects UEFI, which was really cool because just a couple of months later in June 2022, Eclipsium reports that Conti's targeting critical firmware through these UEFI sort of attacks. So something that we're able to do, right, especially on that firmware level, and why we're definitely pulling that research through on the firmware level, is identifying when you're vulnerable to some of these sort of attacks and what that malware looks like for different threat actor groups. So that was a really interesting read. It's called, the Eclipsium report is called Conti Targets Critical Firmware. I liked the read. Basically, I liked it because they were talking about finding basically this chat, right? Conti themselves, the threat actor group, had a data leak And then after that leak happened, they basically had to disband. So they're still around. They're a part of different threat actor groups now, but it was kind of fun to see like sort of the rise and fall of that threat actor group. So this is the message that they sent, and basically how other people determined, CompTIA is kind of doing these UEFI attacks. So, like I said, it's a little bit of a rabbit hole. So I do get off topic sometimes, but all of that is to say that's where we're kind of starting at Zero Trust. It kind of hints at a lot of our background, a lot of the different things that we care about, why we look at certain devices, why we have this certain infrastructure focus. And then that helps us focus in the future. So the things that we know we need to do is the continuation of that firmware analysis, the protection of those edge devices, and then really providing visibility into that system so that we can have a more mature data model. So what we did was circle back around to the CISA requirements and functions, and then we sort of mapped out from a basic standpoint, when we just connect the devices straight out of the box, where are we sitting as far as data maturity? And these green ones are basically ones that are achieved just by pulling things out of the box. I think you can tell we're not getting very far just by, the plug and play aspect of things. A lot of data categorization, data access, visibility is a straight 0 from the ground up. So that was sort of our baseline that we started with. And then we kind of bounced into this year of 2024, where we have our huge literature search. We look at a lot of different publications. We see how people are teaching Zero Trust right now. We've gone to a lot of Zero Trust training, especially Rita. We've done analyses on over 27 IIoT devices. We've got a lot more of that in our infrastructure, but we tend to save it for our interns. It's kind of a fun thing for our interns to do, is analyzing those devices. So that's what they were able to do last summer. And now we have a bunch new interns coming in this summer. So we're really excited about that. Then we're really working on those Zero Trust measures and turning those into metrics, getting really good evidence collection, comparing back to baselines. And then in the end, right, we're working towards strengthening a lot of these Zero Trust for IIoT principles. So like I said, we do have our literature searches. We put some of the clips of our more favorite articles on here. But really, right, what we're looking for is guidance so that we know where the field's at and making sure that we fit into that perfectly. We also do a product review. So looking at other people who are, other vendors who are claiming Zero Trust. And across these different categories, we want to know where kind of everybody falls in line. So some people, right, are going to say, yes, we're doing microsegmentation. It's a buzzword in Zero Trust, so it's easy for people to say, right? Some of these other things, as far as like threat hunting, encryption, that's stuff that people probably aren't going to share just like blatantly on their website. And then also some things like authentication, right? Everyone's going to say, yes, we're doing authentication, but we really care like what kind. So as far as like our own novel concepts, a lot of firmware is pulled and analyzed. We use common format language for our analysis. And we do a lot of graph theory for our interrelationships and the dependencies between that information that we've gathered. As far as measure collection goes, we have a lot of different IoT system measures. The problem, right, is making sure that the stuff that we are using is valuable for the analysis that we're doing, and making sure that the output from that makes sense to people and is used and useful. As far as our codified infrastructure goes, we look at things like the number of communication ports, the number of vulnerabilities, protection profiles, where is your ability to defend from these sorts of things? A lot of people like to say, oh, I did this vulnerability analysis. I found 87 vulnerabilities. You're doomed. But a lot of those vulnerabilities, especially in firmware, may not be reachable, or they may be very, very hard to exploit. So we're looking more into the finer details of a lot of those vulnerabilities to really understand from a protection standpoint, where is your ability to defend? Like I said, we have our we have our basic network diagrams. It's probably the most boring of all of them, but just so you guys can sort of see what sort of devices we have. Anything from smart light bulbs, multi-purpose sensors, cameras. The one thing they didn't let me buy is this coffee pot. It's Wi-Fi enabled, but I was not able to identify why a coffee pot was research essential. So I try again year after year, and I will get my coffee pot. But so far, that's the only lie in this diagram, is they won't let me have this coffee pot. So as far as codified attack surface, this is sort of what leads into our protection profiles, but we use a tool called infrastructure expression. It's a project that Rita ran before Zero Trust existed, and they're able to look at file trees, vulnerability scans, network topologies, and it's all codified into sticks, which is one of those global standards that we were talking about. And what we like about it is it gives you sort of like a visual look at it. So sticks is in JSON. Everything is formatted into JSON as nodes and edges. And then Jed Hale at Idaho National Lab, one of the best researchers I've ever met, he created this application called STIG, Structured Threat Intelligence Graph, which basically puts this, I don't want to call it a front end, but like this graphical user interface for it, I guess, where you can actually create those blocks in a visual way instead of having to write out the JSON, and it creates the JSON for you. And then you can do things like look inside and see, what BIOS language information was found in this HMI. When was it released? What's the revision number? Stuff like that. So we codify every single piece of information that we possibly can. And then we do it in this graph sort of database so that we can understand the relationships that we're seeing. The next steps are, software, hardware, network bill of materials, codified attack surfaces, really understanding how that plugs into your protection profiles, and making sure, again, I keep pounding this, that the data is used and useful. We're not here to just hold data and say we're the best because we have the most data. We need to have the best insights. So we have this video. It's probably a little hard to see on your screens, but what they're showing here is a network diagram and sort of how it works inside of this STIG application. This one was for our solar testbed network flow, and they have like sort of a seam interface here. And essentially what they're going to show you is just different things that they're codifying into this graph, so that you can look at it in different ways. So they have all of their different ports so that you understand how different devices communicate. A lot of the infrastructure expression tools that we have will allow you to store a lot of that communication history. And by a lot, I mean as much as you want, but really why we store that is so that we can do the machine learning and the data analytics and tell you like the actual insights from that. And then we just keep it around for data provenance reasons. And then we are doing a lot in the actual network, different packet captures. Those are all getting codified into graph. Usually the way I just mentioned, usually in the relationships between those different devices, we're able to identify exactly how they relate to each other through their communication profiles. In our actual testbed right now, the last time I checked anyway, it was around 150 MAC addresses, 170 ports. Everything is IPv4. Tons of different protocols, software. Really what we're looking for is a rich distribution or variety of different devices, protocols, anything under the sun that you might see in a building technology. So our Zero Trust devices, we have a lot of initial findings as far as like hardware and firmware. We did do a lot of pulling firmware from hardware last year. In the summertime, our interns did that. And after all of that, we only had one broken device. So we were doing pretty good to only have one broken device after that. I'll give our intern a lot of hard time. She's now full-time. So now I can give her a hard time, but only in a professional way. So, but she also did give us a lot of firmware, collected different device firmware, was able to find open source matches for that. So essentially building up this test corpora of firmware as it relates to zero trust. And then what we're able to look at is known vulnerabilities. So say you're running like this Aerotech smart home hub, and you look online and there's 0 vulnerabilities. So you get really excited and you figure, okay, everything's great. Well, what a lot of people don't necessarily account for is the same thing that we're talking about as far as why we put it in graph. It's the relationships between those devices. So that device has a required proprietary cloud backend that it needs to hook up to. And that itself has 53 different vulnerabilities. And then it uses different protocols, and each one of those can have a few different vulnerabilities. So really what we see is sort of like this ripple effect where you're dropping in these different devices, but every time you do, you're rippling outwards with more and more vulnerabilities as they have different requirements for interacting with the other devices in that network. So we're really trying to understand how those device vulnerabilities sort of add to each other, and how we can more effectively denote those vulnerabilities from the upstart. As far as our measures go, we have a lot of different tools that we're working on to essentially add those different measures and metrics. So things that let us visualize that data, things that help us collect that data, stuff that really helps you understand why things are scored the way they do. So generally people love to have just a number like you're 87% secure, or zero trust. We just do 0, right? Really what we're looking for is visibility into the system that says, okay, why do we come up with the number 87? What math went into that, and how far can we break it down, so that people understand the actual key points in their system that they can update to have the biggest change as far as security and protection. We also have a new tool that we've collected. So a lot of these are updates on other tools that we've done, but with more of a zero trust profile. We do have a new tool called Eve. It takes any of these stig graphs that we're collecting, whether it's network or it's looking at firmware or it's looking at file trees, right? And it evaluates those for quality. It validates them to make sure that they're working with the universal standard, and it enriches them to have better information so that we're really getting all of those ripples that we were talking about. So we call that Eve because it's evaluate, validate, and enrich. And that's sort of like the newest thing that we've created. We have a lot of them, but that was probably the one that was most exciting to me, I guess. As far as turning those measures into metrics, we're not really looking to do it just once for our little area. Really what we're looking for are repeatable processes that can sort of formalize the process. So a lot of that essentially puts us in the subgraph isomorphism area. We're constantly trying to solve that problem. So we're really living in an NP complete world at the moment. But we do get around a lot of that as far as like the way that our graphs are formatted. And because now we have a better understanding of graph machine learning, we're able to really provide good analytics there. As far as like a scientific and technical overview, the things that we really hound on are things like, how are we novel? Are we making a decent contribution, right? And then also, how are we benefiting the scientific community? So we sort of put those as a highlight in here whenever we share these slides. But mostly, what we're looking forward to is this year 3. So, the flexible toolkit that gives validation techniques for various systems, stuff like that, that's actually used and useful and, benefits people, and so that they can understand exactly the analytics we're doing, so they can tell us, well, you guys are a bunch of losers. We would never do it that way. Here's how you should do it instead. We really dig into that. We love that part of this job. So I'll just flash this guy up here. You guys remember this. This was our sort of maturity model. And we looked at sort of where we start baseline. And then it needed to be a graphic. I had a due date, had to be a pretty graphic. So now it's a circle. But this is sort of where we're at now. So as far as like where we were initially, we're working a lot more towards this optimal ring. So in progress research is in pink, existing technologies are in green. So instead of having just like these onesie twosie little things in our data maturity model, we're really starting to build up. So as far as data inventory management, we do a little bit of inventory, but then we add on sort of those like IX tools that can take in a PCAP and tell you what devices are talking and how, and they can format it into graph. So that gives us sort of a foothold into this initial area. And then on top of that, right now we're working on the natural language processing to basically better understand sort of the communication protocols there. And if done right, that will basically score us the advanced area. There's a lot of different things in here, but I mean, like I said, we really focus on the visibility of the system, and that's why we're kind of, if we reach optimal in any of these areas, I hope it's visibility and analytics. So this eval tool, this is something that we highlighted as far as like the first and second quarter of this year. And it's because it is able to take a system that is formatted in STIG and show you exactly which devices are hurting you, and not because that device itself is vulnerable, but because it has a specific poor interaction with something else in your network. It gives that to you in like a number sort of format that speaks to somebody like me, but it also gives it to you in a way that's more visible and interactive that speaks to somebody who maybe isn't a math nerd. And then we always put in year 3 that that's going to be our machine learning, but I am a machine learning addict. Therefore, we have already started that and kind of getting into those metrics and, you know, understanding why those metrics are important. And then, like I said, keep pounding it, but we really want all of the data we're collecting to lead to actual insights, stuff that is legitimately going to help you in zero trust. We're not here just to give buzzwords. So I like this comic. It's like, customers who bought this item also bought the right shoe. So not every piece of information gives, you know, a good insight. So as just a summary, I know I talk pretty fast, but we're building on a lot of previously funded work, but our approach is to continue on with these machine learning toolkits, and then to fund those, or to fuel those, I should say. We're getting right now our zero trust measures and metrics. And thank you for listening. And I can't wait to answer questions if there are some.
Well, thank you. That was very informative, and we do have a question out there from Donnie Willis. What program or programs do you use for your data analytics and data visualization?
Most of our data analytics, it depends on the data scientist, right? Some of them really like creating the visual stuff. They'll use Seaborn, Matplotlib, anything that gives them the pretty graph. Other people will use some of like our other tools, like the IX discovery tools. They'll have ways to visualize it just by importing it into that STIG application that we were talking about. So it gives you sort of a graphical view of it. And then other people really prefer just to look at the numbers. So as far as visibility, that's high, but as far as visualization, it's really low. So as far as something that would be maybe like user facing, that would be something like more of the Eve and eval tools that are letting you sort of dig through. But I guess really my answer is we don't use a lot of programs out there. We usually just build our own because it's easier and we get it the exact way we want it the first time. It's a really lame answer, but I know that there are really good visualization tools out there. We might just be a little bit snobby, just like a little bit.
Are there any other questions? You could put them in the chat or unmute yourself and ask the question. Okay, we had another question. Let's see, great talk. What are your views on applying zero trust to build secure and robust AI, especially attack against machine learning training and deployment phases?
That's a really good question. I would say that my views, my personal views are going to stem from MITRE and sort of So if you've seen like MITRE's attack model, they do the same thing, but for machine learning vulnerabilities. And then that's where they really sort of break it down into sort of what phase those different vulnerabilities come into context. So by understanding really that sort of pattern and knowing where different AI and ML vulnerabilities are is important, right? Because you know where they are, and then you also know when they're vulnerable and when to care about them. And so that those two things together give you sort of the zero trust approach of being able to say, okay, this is a device that's running an AI model. It's retraining periodically, so we really need to keep an eye on it. And when it's going to be a problem is in these specific case scenarios. So it's a lot of the same sort of concepts of, you know, really pumping as much visibility into it as you can. I would love to say we just take the easy route, right? And just say, keep your AI where it belongs and out of my edge devices, but it's not reasonable. So really we need to understand when they're vulnerable and why. It always comes down to the training data, right? There's 50 different names for machine learning vulnerabilities that really just mean you have bad data. So understanding where the data flows are and why they come into context in different areas is really important. So as much visibility as possible, I guess, is my answer, because I don't have enough coffee to say we're just not going to do it.
Okay, there's some other so great talk. One question I have is the heterogeneity of the IIoT devices. They may be sophisticated or relatively basic. Do you have any comments how to enforce ZT for such cases?
I think a lot of it is the problem isn't that some are sophisticated and some are relatively basic. The problem comes in when you have different companies that say, I can turn your basic devices into something very sophisticated, and all it takes is an AI platform. Oh, and by the way, we are putting all of that data that you are curating into our own cloud infrastructure. So really the problem is, you know, understanding why some of them are basic and understanding that when they were created and put out into the world, they were made under the assumption that that they would always be basic. So if you have a basic device, understand it as a basic device, know what the assumptions were when it was put into your network. If you have a sophisticated device, now your job is 10 times harder. Now you have to understand all of the sophistications as well as those assumptions. And that's kind of the only way you're going to reach a zero trust sort of aspect there. Big corporations like Cisco, IBM allocate huge budgets and teams to work on zero trust. How do we work with such projects? Oh, they just call us losers. No, I'm just kidding. They we, like I said, we work a lot with making sure that we take advantage of any of the trainings that come our way, making sure that we understand what zero trust means to Cisco, what zero trust means to IBM. Are we consistent with that? And if we aren't, are we willing to fight that fight? We really are as consistent with those different companies as we can. And as far as like INL goes, by and large, the amount of funding we have for tools, toys, training is pretty massive. So we're very lucky in that way. So follow up, zero trust is quite resource intensive. I agree. What are your views on balancing the system performance and security? Oh, that's a hard one. Obviously it's a balance, but I think at the end of the day, it doesn't matter how I would balance it. It matters how it's actually going to be balanced in real life. And at the end of the day, people don't make money off of security. They lose money off of security breaches and they make money off of usability. So normally what they're going to do is make it as usable as possible until something bad happens, and then they'll start to shift. So I think that as far as applying sort of a balancing act in that inside of the zero trust architecture is really about making sure that we can make the appropriate shift before it's a problem for a business and before you have different security breaches. So what I mean by that is not all security breaches are created equal. And especially with like the shift in AI and ML recently, I would say that a lot of the vulnerabilities there aren't necessarily a quality of service problem. A lot of machine learning and AI vulnerabilities, right, especially like initially back in like 2018 or so, they were really focused on taking down the system. I'm going to make your whole algorithm garbage. But now, with the introduction of ChatGPT and a lot of these generative models, it's more about privacy attacks and seeing what your model will leak. So understanding why those shifts occur help us better balance between that sort of quality assurance, but also security assurances. I don't know if I answered that question now that I think about it. Now that I'm going back through my brain. So if I didn't answer that, definitely throw it back at me. I can try again. Oh, Eleanor, thank you for the resources link. Do we need to create an account to download INL software? That's an Eleanor question. I really don't know. I just have an account.
Yeah, I think that you would have to create an account to download the software because it's developed with US government funds and it's available for you to leverage and utilize, but I'm fairly certain it would require you to provide some information so that we could provide that back to the sponsors.
What threat model do you use to gain insights about AI ML for zero trust in IIoT, and what implications does it have for components in IIoT infrastructure? Probably not just one model in particular. The MITRE one that I mentioned is a big one as far as understanding operationally how those attacks sort of matter to an IIoT infrastructure. Other ones, I'm I'm poisoned, right? So my dissertation was on AI and ML and how it's used for protection, but also how it's used for evil, and also how we apply that. You know, basically I'm poisoned. My insights are pull every model that you can, pull every you know, when you're reading the news articles, can you make that model yourself? What data would you put in it? My model is see for yourself, I guess. But there are other ones that are out there. And if I were to suggest a starting point, it would be CISA and MITRE. What is the significance of the extra I in IIoT? Oh, industrial. So industrial Internet of Things. So maybe less so what you would see in your own home, and more so what you would see. We focus on sort of like the building technologies, and I would say that's kind of like the happy point between the two. I can see, you know, small offices where their IoT is going to look a lot more like a home than, you know, a big building. But stuff that we're looking at where it's like, what would you see in a giant office building if it were to be a part of, you know, this industrial Internet of Things sort of idea. Rita Foster, like I said, she is an absolute genius as far as industrial control systems go. And she can definitely speak a little bit better to sort of like how IIoT affects like that sort of industry. And Rita's here. She's here and she's been quiet. She's been letting me just, yeah, and then she appears in the chat. She's also an expert at chickens. So if you guys have any questions about like chickens and what they do this time of year.
Yeah, I brought in 24 eggs and shared them with an intern and an admin, so I know how to suck up to my coworkers. So yeah. But yeah, the industrial Internet of Things, there's a lot of these commodity devices that are happening in industry, in manufacturing, or in the electric grid. I mean, there's still some huge heavy metal devices out there that are going to be, you know, extremely important for our critical infrastructure. But we are seeing this wave of industrial Internet of Things. The building technologies is fascinating because they incorporate things like power inverters for solar, microgrid type capabilities for you know, power qualities, and so it's a little bit beefier. That's why we kind of picked the building materials, because when you get the building manufacturing or building management systems for large areas, there's a lot of energy and a lot of power related equipment that's connected to it. That's why it's that sweet spot. Things you may find in your home, like a sensor or a light bulb, but also power inverter as well of larger magnitudes.
So when you were talking about control systems, and at the beginning of the presentation, you said you all were not doing anything with OT, but from a SCADA perspective, are you planning to do any of that, looking into control systems, the different vulnerabilities around, PLCs and whatnot?
Yeah, the Idaho National Labs has a decades of history of doing vulnerability assessments on different devices. I did some analyses on it at different times, but we've done vulnerability assessments on probably about over 100 different configurations, whether they were given to us by a manufacturer or an asset owner. A lot of other smaller devices as well. And we're a research lab, so we evolve. So that happened like 2003 to 2009. Then we started evolving and doing other things. And right now, a lot of our work and a lot of our focus is how can we use these new tools, these new concepts to make things more secure. So our reverse engineering at scale that was developed by Jed Hale that we have implemented in many different use cases works for firmware, works for malware, works for systems. Our codification of infrastructure allows us to use graph analytics for some large infrastructures, do automatic applicability to emerging threats, and enrich that, make it used and useful, like Shea was saying. So we've evolved what we've done, but yeah, we have a huge wealth of knowledge of vulnerabilities, and now we're really focusing on how to protect things better, how to make things better, how to engineer better controls from the way in. Proposal that I submitted, I'm going to present tomorrow. Next week. We're trying to figure out how to change up things so that we can actually work on the engineering side, do trade-off analyses on engineering requirements. So before you build the system, can you engineer in and design in better concepts? And that's part of our cyber-informed engineering work.
Okay, great. Thank you. Any other questions from anyone? Okay, I don't see anything in the chat. Well, Shea, this is a great presentation. Thanks, Rita, and thanks, Eleanor. She helped set this up. Eleanor is our go-to person at the Idaho Labs with NCyTE and other for our coordination of academia and cyber. So we thank you all. Mike, I'll turn it back to you if you have any. One other thing before. I have my NCyTE, I have my SciAd t-shirt on because in June, we actually have our SciAd conference. It's the NCyTE sponsored conference for multidisciplinary workshops and sharing of information with the different national centers, faculty, so that we can incorporate cybersecurity into like manufacturing and other types of critical infrastructure. So just a shout out on that. And again, thank you all for the presentation. It was fantastic. I'll turn it back to you, Mike.
Thank you. I was just going to echo what Stephen says. And Shea, thank you for a great presentation. Anybody who puts John Travolta in their presentation, I've got to say thumbs up to you. That was awesome. Thanks again, everybody, for attending today's meeting. We really appreciate your support. And please send us your feedback as I dropped the link in the chat. So we would really appreciate your feedback on that. With that, I'm going to say have a great 3-day weekend for those of you who have a 3-day weekend or just want to use Monday as an extra day to work. So take care, everybody. Have a great Memorial Day weekend. Bye.
Thank you all. Bye.